Hello everyone, it's Phil here with another video. In this video I'm going to show you how to build a high performance slot 1 retro gaming PC specializing on Windows 98 and very late DOS games that allow you to run DOS games in high resolution. As always, this is not a recommendation that is set in stone, it's just something I put together. Now every part I choose I will explain a little bit about why I chose it and what my reasons are, but there are lots of alternatives, so don't think like you have to build it this way or the parts that I use are the best. They're not. Everything is subjective, so this is just one little machine I put together and I wanted to share with you. So I'm going to talk about all the parts, then we're going to look at the BIOS options, we're going to install Windows 98, all the drivers, and then at the end we're going to do some benchmarking of the storage and a couple of games like Quake, Quake 2, Quake 3 Arena. There's also the some DOS benchmarks there, some Duke Nukem gameplay in 1024 by 7068, and a lot more. Choosing a decent motherboard is quite important. I do recommend you go with a good brand, Asus, Aopen, Gigabyte, one of those. You will still find all the drivers from the manufacturer websites, which is very handy, and also the documentation, how the jumpers work and so on. Most motherboards do have the information printed on the PCB, so that's very useful. Always check for issues with the capacitors. The reason I'm choosing Aopen is because they tended to use Japanese capacitors, and I have 3 of these boards and they all work, so that's a brand and a model I recommend. It is the Aopen AX6BC. I also recommend that you clear the CMOS, the BIOS, it has a jumper setting for that, and also replace the coin battery if you're not quite sure how old it is. It just costs a few dollars and it's a good thing to do. I also like to assemble my gear outside of the case just to make sure everything works before I install it into a case. The floppy connector on this motherboard is a little bit awkward, but otherwise it's a really reliable and solid motherboard. The processor I'm going with is a Pentium 3 1.1 GHz, and that's the 100 megahertz frontside bus model. A little bit hard to find, but you might find the 1 gigahertz version a little bit easier and cheaper to source. I'm using a slot 1 to socket 370 adapter and also a StarTech socket 370 all copper cooler. Really good combination, lots of performance. The Intel 440px chipset is specified for 100 MHz frontside bus. I'm aware that you can overclock, but it's not something I do. If I need more performance, I'm just going to build a Pentium 4 and be done with it. There is also another type of slot 1 to socket 370 adapter, which can take the, and I'm hoping I pronounce it correct, the Intel Tualatin 1.2 and 1.4 GHz Celeron chips. But these adapters are very hard to find, and I doubt that you're going to get a lot of extra performance compared to just going with a 1 GHz or 1.1 GHz Coppermine Pentium 3. For the RAM, nothing special. It's a 256 megabyte stick of SD-RAM. I believe it's PC 133. I do recommend that you go with PC 133 because that means at 100 megahertz you can run it with tighter timings, and I'm going to show that later when we look at some of the BIOS options. Windows 98 has a memory limitation of 512 megabyte. Again, there's a patch, a modification you can do to get around that, but if you need a machine or running software that needs more than 512 megabyte of RAM, maybe you should be looking at using Windows XP instead. For the graphics card, I chose a NVIDIA Quadro FX 2000. Now that's a workstation card. It's the equivalent to the GeForce FX 5800, and the reason I got this card is the workstation card is actually cheaper to buy on eBay than GeForce cards. For some reason, no one is interested in workstation cards. Kind of makes sense. Everyone is collecting and trying to get GeForce cards, but the workstation cards are pretty useless. So if you look a bit around, you might grab a bargain. Compatibility is very good. I had no issues with the drivers. The fan on this card is a little bit on the noisy side, especially when you turn on the machine, it's very loud, but then it settles down, and during gameplay, it's actually not that bad. In terms of other graphics options, there are lots of options, but we're really trying to go for something high performance. So we want really high resolution, high frame rate, 32-bit color depth, and NVIDIA is really the way to go. So I don't want to start a war here, but if you want an easy life and you want games to just work on old computers, go with an NVIDIA card. Things just work a lot better. With the power supply, I do recommend you get something modern and current. Old power supplies do have a tendency to have lower voltage tolerances, and that might be causing stability issues. And I know a lot of people where the power supply blew up and took some of the expensive retro hardware with them. So I do recommend get something new that works and you'll have less dramas. Having reliable storage is also very important. The solution that I use and tend to promote is using modern SATA hard drives and using C-tools to limit the capacity. So because of that, I do recommend Seagate and Samsung hard drives, because C-tools works with those models. So in this case, I've limited the capacity to 120 gigabyte. The drive is actually a fairly recent 2 terabyte drive, so lots of performance, low access time, and limiting it to 120 gigabyte makes sure that the BIOS of the motherboard supports it, but also avoids any issues with Windows 98. So Windows 98 has a 128 gigabyte capacity limit. Once again, there are modifications around that, but I like to keep things stock. So how am I going to connect this to the computer? By using a SATA to IDE adapter, and they work very well. DMA mode can be easily activated by just ticking the box in the device manager, and I found this solution more reliable than using PCI SATA controllers. I've got some silicon image PCI SATA controllers, and although they work, and even after installing the driver, I never got the speed. It always felt like DMA was not working, and in benchmarks it's a lot slower than using the SATA to IDE adapters. So that's the solution that I've been using across a ton of my systems, and that's the solution I recommend. For the optical drive, I do recommend that you stick with an older IDE model and not a SATA drive, and that's because we need the analog audio output at the back. A lot of games from the Windows 98 era still use CD audio tracks, and that's why you need the analog output at the back. So this is a, don't even know what brand it is, I think it's a Light-On, a standard DVD ROM drive, and you can read burnt discs as well. So nothing fancy here, just get an IDE drive that works. A favorite of mine, the GoTech floppy emulator. I use it in all of my machines. Sometimes Windows 98 likes to probe for a floppy drive, and if it doesn't find it, there can be a delay like during the installation, but it's just good to have if you quickly need to transfer a file. That's a very good solution. They're cheap, they're really reliable, avoiding the issues of having floppies that don't read anymore, and that happened to me all the time, so I got really fed up with that and can't recommend them highly enough. They really work very well. And we need a sound card, and there are lots of options. Now this motherboard has ISA slots, so you can go with an ISA card. However, the focus here is really on high performance, mostly Windows 98 games, so I went with a PCI sound card. However, this card is actually really compatible with DOS as well, so you can still play your old DOS games, and especially the late DOS games, they are highly compatible with PCI sound cards. It's just those really old games like from Sierra or LucasArts where you run into issues with PCI cards. But all the games you see later in the benchmark, the DOS mode of this card works really well. So it's the Diamond Monster, the MX300. It uses the Oriole Vortex 2 chip and has the A3D surround over headphone technology going, and a lot of Windows 98 games use that. But it's also got a wavetable header and a MIDI port, so you can hook up a sound canvas or Yamaha MIDI module, or use a wavetable module, and that even works in DOS, so you can still get MIDI under DOS as well. Great card. The drivers are fairly straightforward as well, and haven't had any issues, and I've been using this card for a lot of my Windows 98 tests and setups in the past. And here we have a PCI network card. It's a standard Realtek NIC, nothing special about it. I like to use networking. I connect to my capture machine, which is right next to it. I've got a shared drive there, and I can also use FTP to connect some of the hard drives that are connected to my modem router. And I've got drivers on there. It just makes it easier to set up a new machine. And we also need some IDE cables. And another thing we need, well, not need, but I do recommend it, having one of those little PC speakers, one of those buzzers, just to make sure that the machine posts correctly and turns on. And I also have one of these front header connectors, which allows me to just power it on my test bench. Okay, now it's time to put it all together. I've assembled it onto my test bench, and that's where I'm starting installing Windows and everything. So we're going to have a look at some of the BIOS options. I'm going to walk you through some of the installations, and towards the end we're going to do some benchmarking, and we're just going to find out what this machine is capable of. Okay, so I've just turned on the computer, and at this point you're just going to see that the processor is detected, the memory, it picks up the hard drive and the DVD drive, and then we get a little error down below that there's a CMOS checksum error. That's because I cleared it with the jumper. So here we're doing a bit of housekeeping. I usually load BIOS defaults, but this one has turbo defaults, and then I run the auto detect, so it makes sure that it picks up the hard drive. So here it picks up the 120 megabyte hard drive. It also speeds up the boot process because it doesn't have to look for all the drives every time. Quite important, I disable any resources I don't use. For example, the two serial ports and the parallel port. I make sure that plug and play is set to yes, because Windows 98 is a plug and play operating system. I disable power management, I'm not interested in that. And I make sure that the RAM timings are set to the lowest, but only do that if you're using PC 133 memory. To double check, you can always run CPU set on a machine that has the RAM stick installed to make sure it's all good. And here I'm just checking that the floppy is set, and save the settings and confirm. Okay, I also forgot to mention that I did disable one of the video BIOS shadow options, and also made sure that the boot order is set so it boots from the CD-ROM. And then you just boot from your Windows 98 SE installation CD. I've built myself a special one that uses an automated answer file. But basically what we're doing is we're partitioning, formatting the hard drive, and then installing Windows 98. To partition, you use fdisk. In this case, we've got a 120 gigabyte partition, and fdisk will do it, but it will report incorrect capacities. So this is just a cosmetic issue. Just ignore it. Just go with the full size, using the full size of the partition, and at the end you will have a 120 gigabyte partition. After you've partitioned it with fdisk, you have to reboot your machine and then format the partition using the format command. I'm just going to fast forward this video because it's a very boring process to watch. And after that, you just start the installation from the Windows 98 CD by running setup, and choose all the options. In my case, I'm using an automated answer file, so it I don't have to enter it manually, and will be back shortly when I'm gonna start installing some drivers. And here we are on the desktop, and I did a bit of housekeeping, just deleted some of the icons on the desktop, and I've got a driver CD, and on that driver CD I've got the service pack. It's an unofficial service pack 3.45 I believe, and also my drivers for my network card. So what I'm doing here is, firstly I'm going to install that service pack, and I'm going to go for just two options: the core installation files, and also the option that enables the DMA mode for the hard drive. Once that's done, I'm gonna install the network driver, and I do that by going through the device manager and manually pointing it to the drivers on the CD. After that's done, I'm mapping my network drive from my capture computer so I can access that shared drive, and then I'm installing the NVIDIA graphics driver. So again, because that's quite a boring process to watch in detail, I'm just gonna fast forward this video part. Okay, so at this point, my network is working. That's why it's asking me to confirm the login. I don't have to use a password. And what I'm doing now, I'm just increasing the resolution from the default resolution, which I believe is 800 by 600 or something like that. So by right clicking and going into the NVIDIA driver, I'm just gonna increase the resolution to 1024 by 768. That's a good resolution for the monitor, and my capture card also supports it very well. And here we are, looks a little bit nicer, doesn't it? Now what I'm doing now is installing the drivers for the sound card, for the Oriole Vortex 2 or the Diamond Monster MX 300. And now that I've got access to my shared drive, I can just do that through the network. Now I ran into a little hitch here. The Sound Blaster Pro emulation, it got assigned DMA3, but you really wanted to have DMA1. It's not a big deal. It's really easy to fix. All you have to do is go to the device manager and look at the properties for the Sound Blaster Pro emulation, and under resources you just change the DMA from 3 to 1, and after reboot everything is working. Okay, time to do some benchmarking. We're starting with testing the storage. So I'm using ATTO benchmark, really good benchmark to test your hard drive. Again, I'm going to fast forward it because it takes quite some time, but we can see that the SATA to audio adapter works really well, and it's basically reaching the limit of the audio controller, which is a UDMA 33. Anything beyond that, you really have to go with a high motherboard that has a better audio controller. But 33 megabytes a second is a fantastic throughput, and you should not have any issues to do in regards to having a reliable and fast storage. Okay, so let's see what this machine can actually do. Now I've done quite a few benchmarks. Some of them take longer, so I'm not going to show them in the video. I'm just going to walk you through the results. First, I tested under Windows in 1024 by 768, and I got for GL Quake 381.9 frames, for Quake 2 211.3, and for Quake 3 Arena 112.1. Incoming benchmarked at 163.79 frames, and expandable at 60.77, Forsaken at 283.67. I also benchmarked at 1600 by 1200 resolution, but incoming incoming did not support that resolution, so it's 1600 by 1200 resolution, and I don't have a video capture for that because my card doesn't go that high. At 1600 by 1200 resolution, we have 262.4 frames for GL Quake. We've got 106.8 frames for Quake 3 Arena, 136.9 frames for Quake 2. Expandable gets 53.97 frames, and Forsaken 273.82 frames. Now I've also benchmarked under DOS using my VGA benchmark database project. There's a file you can download that has a benchmark menu, and it does it all for you. We're getting 824.7 frames for 3D Bench, 239.5 frames for PC Player Bench, 840 frames for Doom, and 158.3 frames for Quake. Now I also tried 1024 by 7068 resolution under DOS, and in PC Player Bench we're getting 56.9 frames, and in Quake 33.9. And at the end I've got a bit of gameplay footage of Duke Nukem at 1024 by 7068, and it felt really smooth. So that just shows that that machine is powerful enough to run some of the DOS games at high resolutions. And here we're looking at 1024 by 768 resolution under DOS. DOS high resolution can become very, very demanding very quickly, so you need really beefy processor, because a lot of games do it through software. They don't use 3D acceleration, so very powerful processor is required. But this machine is not too bad. It can handle games at 1024 by 768. So we're just having a look at PC Player Bench, at Quake at 1024 by 768, and then we have some gameplay footage of Duke Nukem at that same resolution.
Let's rock. Damn, those alien bastards are gonna pay for shooting up my ride.
And that's it for this video. Thanks for watching. As always, hit that like button, subscribe to my channel if you haven't done so. Any comments and questions, leave them down below. And hopefully, or maybe I'm inspiring someone out there to build a similar high performance slot 1 Windows 98 /DOS retro gaming machine.